Welcome to the course Business Analytics and Text Mining Modeling using Python. So, in previous few lectures we have been focusing on the built-in capabilities that are available in Python platform, and data structure part, most of it we have been able to cover. And now let us move to the next aspect, that is errors and exception handling. So, this is mainly required to be able to write robust programs, and for this we have this mechanism in Python where we can use try except blocks, and using these blocks we would be able to deal with certain errors, certain exceptions that are sometimes required to be handled. So, let us start. So, first we will talk about the improper input values. So, it might so happen that we are passing an argument to a particular function which is not accepting a particular kind of input value. So, in that case it might throw some error. So, how can we use the try except blocks to handle that kind of error or exception. So, let us start. So, first thing, improper input values. So, when we are saying improper input values, then we might get into this exception, value error exception. That means the input values, the appropriate input values was not passed on. So, let us run this. So, what we are doing here, we are calling this float function, and 1.2345 we are trying to convert this value into a floating point number. So, because this is a correct input, so immediately we get the output without any error or exceptions. Now, if we try the same function float and pass on the value as a string value as an argument, let us say something. So, you can see in the next line that I am going to run, the only argument that we have here, we are passing a string value here. However, the string value cannot be appropriately converted into a floating point number. So, therefore, this is an improper input value, and therefore, we will get into value error exception. So, let us run this, and you can see that we have got value error this exception, and you can see could not convert a string to float. So, something was the string that we passed. So, it could not be converted into a floating point number because it is an improper value. Now, if we run into this kind of problem, how do we handle this in our code? So, for this we can use try except blocks. So, in this we would like to define these kind of blocks. So, we will use the def keyword, and we are writing this our try except blocks. This is attempt float 1, attempt underscore float 1. So, this value x is the argument that for which we are writing this, and then we have this try keyword, try colon, and then return float x. So, if the value is proper, then we will be returning the returned value of the float x function. If the value is not proper, then we will run into the except block, and we will be returning this message improper input value. So, that the coder or the analyst will know that improper input value was passed on. So, let us run this block. So, now after defining this try except block attempt underscore float 1, if we pass on this 1.2345, then there should be no problem here. So, you can see we got 1.2345 as the output. However, if we again try something that string value, and we try to pass it on to this new function attempt underscore float 1, and in this if we run this, you can see improper input value as the output, because that value was not found to be appropriate. So, an exception was thrown. So, to deal with that exception, we have written this try except block within this function. So, in a sense this is a wrapper to the original attempt underscore float 1 is a wrapper to the float function, where if any exception is thrown, we are handling that within this particular wrapper attempt underscore float 1. So, instead of using the inbuilt functions that are there in Python platform, we can write our own user defined functions, so that any exceptions and error handling could also be done. So, let us move to the next example. Now, this is about second kind of exception that we might have to handle. So, this is improper input types. So, it might so happen that a particular input type, a particular data structure is not accepted by a particular function, but that is being passed on. So, this is referred as type error exception, where a wrong kind of type has been passed on. So, in this case, again we are using the float function here, and you can see in the parentheses we are passing just one element, which is a tuple object here, and having two elements 1 comma 2. However, the float is not supposed to accept this kind of type. So, because of that we are getting type error exception. So, the argument has to be string or number. You might think that string is also not something that should be acceptable. However, in the string format we might pass on a numeric value. So, a numeric value within double quotes or single quote, it could be a string value, but it can be appropriately handled by the float function. So, string as an allowed type. So, you would see that if I run this in the error, you would see that type error, float argument must be a string or a number. So, because in a string there is a still possibility that a numeric value can be passed on within the double quotes or single quotes as a string value. So, to be able to deal with that cases, we the float argument accept the string also as an argument in Python. However, tuple is not accepted here. So, for tuple we are getting type error exception. Now, how do we manage this? So, for this again we can write a wrapper function here, def attempt underscore float 2, and in this function again we are defining certain try except blocks. So, you can see we have one try block and then two except blocks. So, here in the try block as before we are returning the float x. So, if there is no error, no exception that has been thrown, then we would like to return the whatever return value we get from float function. Now, the second except block is handling the value error, which we have already discussed. So, if the improper input value like string value where the characters are there like something that we did. So, to handle that we have this exception block here except value error, and we are returning this improper input value. Now, the second case that we are discussing now type error. So, we have the second except block here except type error, and in this case we are returning the improper input type as the message. So, that the user or the coder or the analyst will come to know that the improper input type was passed on as an argument to the function. So, attempt underscore float 2 in this second wrapper function that we have that I have written here, we are handling both these types. We have two exception blocks, a value one for value error, the another for type error. So, if I define this, if I run this line of code, and now this function would be defined. Now, if I pass on an appropriate value 1.2345, you can see this appropriate, this is being passed in within the single quotes here. So, if I run this, there is no problem in this because it's string. This is a string, but it can be appropriately converted into a numeric value and therefore converted into a floating point number. So, this is okay. Now, in the second example I am passing on something. So, in this case this is an improper input value. So, if I run this, so you can see improper input value. So, because something this particular string is made of characters. So, this is not acceptable. So, we have already handled this exception. So, we have got the message improper input value. Third example is that where we are passing on a tuple. So, attempt underscore float 2, and in the parentheses we have just one argument, and that is a tuple made of two elements 1 comma 2. So, if we pass on this, so a exception type error would be erased here, and that we are handling in this function attempt underscore float 2. So, if I run this, we will get this message improper input type. So, in this fashion you can see depending on the kind of exception scenario that we might expect, depending on the kind of data that we might be dealing with, certain scenarios might be possible. So, we can always write these kind of wrapper kind of functions which will have try and except blocks, and we will be able to handle different scenarios, and in this sense we will be able to write and develop robust programs. So, when we say robust, so we would be able to handle different kind of inputs, different kind of scenarios, errors and other things that may happen there. Now, let us move on to the next aspect. Earlier example that we have just discussed, there we were handling these two, there we had two except blocks, and we were handling value error and type error separately. However, we can use try and except block, where we can write except block which can which can catch multiple exception types using just one statement. So, how do we define that? So, this is the example. You can see now we are writing another function here, attempt underscore float 3, and in this case you can see that try block is same as before. We are just returning the float value, and then we have just one except block. However, we have in the parentheses we are mentioning both kind of exceptions, value error comma type error. So, this is a tuple. So, these two exceptions we are handling, and if you look at the the return message that we have here is improper input value or type. So, it could be either value error exception or type error exceptions. So, in one statement we are trying to handle, we are trying to catch multiple exception types here. So, in this fashion we can define this function and handle these kind of exceptions. So, let us run this. Now, you can see next example that we have attempt underscore float 3, and we are passing a numeric in the string form, in a numeric value in the string form. So, if I run this, we will get this floating point number, and next example again we are passing on something, this string value to this attempt underscore float 3 function, and if I run this you can see I am getting improper input value or type. So, we are not it might not matter us to deal them separately, rather we can club them in this fashion using one except block, and we can adjust our messaging also that improper input value or type. So, one of these two things occurred, and that we have handled in one multiple exception have been handled in one statement or one except block. Now, if we pass on tuple, then again we will get the same message. So, this is the way to handle this. There might be certain scenarios where we would like to execute a code block regardless of whether try block succeeds or not. So, to deal with these scenarios we have another another keyword, another block that can be used, that is using finally block. So, in this case whether the try block succeeds or not, this is this code block is going to be executed. So, let us take this example here. So, the example that we are taking here is about generating locks or cleaning up the Python objects. Given any scenario we might be creating and initializing and processing many Python objects. So, irrespective of the irrespective of the code that we are writing, we would always like to clean up the Python objects that we might have created, we might have used. So, this kind of situation we would like to, this kind of code execution we would like to perform irrespective of whether a particular try block succeeds or not. So, in such situation we might also prefer to not suppress exceptions. In this case we can use the finally block. So, if you look at the code that we are writing, that I have written here. So, first thing is I am opening this temp.txt file, and in the file mode is write. So, this is write only file mode. We will talk about file handling in detail in later lectures. However, in this example we have just opened a file, and we get file object fl, and the file is going to be opened in the write only mode. So any message that we would like to write in this file, so you can consider this like a logging thing. So we are trying to create a log here, generate log here. So this file log file has been opened in the write mode. So then in the try block we are writing fl dot write and done. So in a sense in the try block succeeds, then we would be will have done message there, and then we have the except block. So in that case some exception is there, then we would be writing in the log not done. So that would be written there. Now we have the finally block here. So again finally and then colon, and then we have this block here. So this particular block is going to be executed regardless of whether the try block succeeds or not. So what we have in this block, fl dot write and log 1, fl dot write log 2, and fl dot close. So we will be writing these two statements there in that file. File object fl, and that means this file temp dot txt, and then we will close this file object. So in a sense we have recorded our log statements, and then we have cleaned up the existing Python objects, which is in this case this fl, this file object. So let's run this. So once we run this, we can always have a look at the log that we have just generated. So for this we will have to use this read method. So fl dot read. So if I run this, you see I get an error here, IO operation on closed file, right. So this error we have received. So actually what is required is that the file was not opened in the read mode, and the file was actually closed. So first we need to open the file in the read mode, and then we will be able to read the contents of the file. So by default in Python platform the files are opened in the text mode. So we can first open this file fl1, this new file object open temp dot txt. This file object fl1 would be created in the read mode, and then fl1 dot, then we would be able to read the contents of that particular file. So let's run this, and you can see in the output we have got done log 1 and log 2. So you can see why we have got these messages, because if we go back to the block that we had run, you can see that first the try block has succeeded. So we got the message done here, and then once after that finally block is going to be executed regardless of whether try block succeeds or not. But in this case try block succeeded. So then we'll have log 1 and log 2. So those three those three messages are actually written in this log file, done, log 1 and log 2. Now let's close this file fl1. There might be certain scenarios that we would like to execute a code block only if try block succeeds. So only the try block goes through, only then we would like to execute this certain piece of code. So for that we can use else block. So how to define this? So again we are taking this the same example here. The temp dot txt file we already have, we also have some data written in this file. So let's open this file fl2 file object, let's open this temp dot txt in another file mode, right, A, which is for appending in the file, appending any content in the file. So first we have the try block here and fl2 dot write. So we are typing done, and if this block succeeds, only if this block succeed, then if we want to execute a code, then you can see we have the else block here, and in this we are printing this statement succeeded. So this particular else block is only going to be executed if the try block succeeds. If the try block fails, then the this else block is not going to be executed. The except block might be executed, where we have the print failed statement, and the finally block is also there. So finally block will also be finally block will also be executed. So we will be closing this file object. So let's run this. So, if I run this, you can see here that we have got this message succeeded here. You can see this succeeded message we have got here. So, that means the try block that was successful, that succeeded, and therefore, else block was also executed, and therefore, we have got this we have printed this message succeeded. So, two additional block in addition to the try and except block that we typically have, we can have these two additional blocks else and finally. Now, let us move to the file management aspects in the Python object. So, how do we work with files in Python? That is quite simple in this particular language platform, and Python is particularly very popular for text and file munging. So, we'll talk about the file management aspects now. So, one of the important thing that one of the first thing that we do in file management is to open a file, and there are various operational mode to open a file. It could be read only mode, it could be write only mode, it could be read and write, and various other modes are also there. We will be discussing them. So, first thing is opening a file in a particular operational mode. So, by default the file is open in the read only mode, or the open function we have already discussed and used in the previous examples as well. And as far as the file path, that is the first argument that is to be passed in the open function, it could be relative or absolute. So, we can give either the full path in an absolute sense, or if we are working, if we have all our files in the working directory itself, in the current directory itself, then we can just use the relative addressing and just give the name of the file that we want to open. So, here I am defining a path variable here, path temp1.txt, and I would like to open this file, open this path here, file path object here. So, if I just try to run this, I will get an error here that no such file or directory temp1.txt. So, this example I have written actually to tell you that if the file does not exist, we are going to run into this kind of file not found error. So, first we need to ensure that the file is there. So, temp.txt is the file that we already have there. So, we will run this again. So, next file object fl3, and we will run this, and this file is already there. So, we will just use it for to discuss other aspects. So, now let us talk about the read method. The use of read method is that whatever data that we want to read, we can indicate in the arguments, or if we do not indicate all the data that is part of that file, that would be returned in the form of a string. So, read method returns data from file as a string. So, in the fl3 dot read, in this, if I run this, if I make this method call, so you can see we have got this string as an output, done, then slash n, then log1 slash n log2, then slash n done and done. So, this is the string that we have in this file. So, this is how we can read it. Now, once we read a file, we might reach to the end of the file. So, in that case, if we again read the file, then an empty bytes object is going to be returned. So, if I run the next line again, if I repeat fl3 dot read again, if I execute this, you can see an empty object has been created because we have already reached the end of the file. Had we passed on some integer value as an argument to the read method, then those many characters would have been read and would have been given in the output, and the file position will also change, and the next next reads will start from those positions. So, in this case we had returned all the data in the previous call. Therefore, we reached the end of file, and therefore, an empty bytes object is returned in this case. Now, we have also used the close function. So, the main purpose of this particular function is to closing the file objects that are typically created with the open function. So, this is an important cleanup operation, in the sense the resources that are involved in in a particular file object, they would be returned back to the operating system. So, this is a cleanup operation. So, it is recommended to always close all the file objects. So, if I run this fl3 dot close, then this particular file object is going to be closed. Now, there are going to be certain scenarios where we would like to iterate over the lines in a file. So, in a file we might be having text data, and we would like to iterate over the lines of data that we might have in that file. So, how this can be done? So, we can treat file handle as a list, and then this iteration over that handle can be performed. So, here is an example. So, first thing, we are creating this file object fl3 open path. So, that temp.txt that we have created, that file is going to be opened in the read only mode, and then we are running a for loop. So, for line in fl3, and then we have pass. Remember, we had discussed the pass keyword before. So, if we do not want to do anything, any operation, then we can use the pass keyword. We had talked previously that, because we do not have any braces or other those kind of that kind of syntax that is typically used in other languages. Therefore, we require this kind of a statement if we do not want to execute anything. So, in this case, we just wanted to demonstrate that we can iterate over the lines in a file. So, this is how we can do it. So, if I run this, so because we have iterated over all the lines in this file, therefore, we must have reached at the end of the file. So, therefore, if I try to read this file in the next line that I have fl3 dot read, then I should be expecting an empty bytes object. So, that is the case here. You can see in the output number 26, we have got the empty bytes object, because we have already iterated over all the lines in the file. Now, there is something called end of line marker. So, by default /n is the end of line marker. So, let us take an example to understand this aspect as well. So, let us open the file temp.txt open path. Path is indicating that file name temp.txt, and then we are running a loop for line in fl3, and the only statement that we have in the for block is print that line. So, we would be iterating over the lines in this file, and we would be printing each line. So, if I run this particular code here, you can see I have got done log 1, log 2, done. So, you can see that each of these lines have been printed as a new line in the output. So, that is itself is indicating that /n is the end of line marker here, is /n is being used as the EOL marker here. Now, sometimes you might know, you might not, you might want to have a check, or you might forget to remember that whether a particular file object is open or not. So, for that also we have a method called closed. So, this particular closed method is going to return true if the file is closed. Otherwise, if the file is open, then it will return false. So, in this case, you can see that fl3 file object that is still open. We have just printed all the lines in that fl3 in that file. So, if I run this fl3 dot closed, because this file is open, I should get false as the return value. So, you can see this. So, this can be really useful when we want to put a check somewhere to make sure whether a file is open or not. Now, if I again if I try to read this file here, you can see that that empty bytes object is returned here. Now, sometimes you might want the list of lines which are free from end of line markers. So, that can also be done. For that, we can use list comprehension, where we have this transformative expression line dot rstrip method. So, it will strip the line of any end of line markers, and we are iterating over all the lines in that file. So you can see line in this list comprehension in the within the brackets we have line dot or strip and then for line in open path. So if I run this, you can see all the lines that we had in this file. So we get a list of all those all those statements, all those lines done, log 1, log 2, done, done. So in this end of line marker is gone, that has been stripped off. Now I can close the file here, fl3 dot close. Now another aspect is cleaning up open files. So though we can use the close method to close any file object that might be there. However, sometimes it might be difficult to track all the file objects that we might have created. So for that to ease that aspect, cleaning up aspect, we have another another keyword and blocks that can be used. So this is bit keyword. So this is actually used to perform automatic cleaning of resources like file objects after the execution of bit block. So whatever is there in the bit block, once that part is executed, all the file objects, all the resources, they are going to be cleaned up. So let us take an example here. So bit keyword, then with open path as fl4. So essentially this is we are creating this fl4 file object with this function open path, and we have just a one line in this bit block where we would like to, again we have the list comprehension. So line dot r strip for line in fl4. So essentially we will get the list of these statements, the lines that we have in the file. So if I run this, you can see that fl4 that we can have a check whether fl4 file object was closed or not. So now perform this fl4 dot closed. If I run this, you can see true as the output. So the output that's this list comprehension that was performed, and once that is executed, if we check whether the file object is still, whether the file is still open or not, you can see fl4 dot close, that is true. So cleaned up, automatic cleanup of resources has happened. So we can always write our file management, file processing that we want to perform using the bit keyword. So this will ensure the automatic cleanup of resources. Now once the file is closed, if I try to read this file here fl4 dot read, you can see I will get this value error, IO operation on closed file. Now let us move on to the other aspects here. So there are other Python file modes. So let us talk about the file modes which are typically used for writing. So one thing is this would be used carefully, because purpose of sometimes for different we might have different writing different scenarios for writing content in the file. So we have different file modes that can be used to cover all of those scenarios. So first one is the write mode, write only mode. So for this we have within single quotes we have to specify W. So this write only mode, this is used to create a new file, and once we use this write mode, if there is any file and having some data with the same file name, then that is going to be erased. So if we have a temp.txt and some data is there, and if we create a new file object and we open the same file in the write mode using W, write only mode using W file mode, then the previous all the data that would be gone, because we would essentially be creating a new file with the same file name. Now the next file mode is small x within single quotes small x. So this is also write only mode. Only the operational part of this file mode is slightly different, in the sense we create a new file if the file path does not already exist. So this is to address the scenario where we might already have an existing file, and therefore if the file is already there, we might not like to create another file. So in that case we can use this file mode X. So it will open the file in the write only mode. However, if the file with the same name is already existing, so opening of that file in that write only mode will actually fail. Now there is certain scenarios we might like to add content in an existing file. We would like to write content into an existing file. So, for that we have another file mode appending. So, this is within single quotes, so we can type A. So, this is to append to existing file, and if in case the file does not exist already, then it is going to be created, and whatever content we want to write, that would be written there. If the file is there, if the file is existing and we want to write something, so at the end of the file the particular content is going to be written. So, let us take an example here. So, we will take the example of this file mode A, which is for appending to existing file. So, we will have fl5 another file object here, an open function, and we are passing this file temp.txt that we have already created. So, we are using A as a file mode. So, that means whatever we want to write, that is going to be added at the end of the file. So, we call the file function fl5 dot write, and if we want to write this string appended, so this string is going to be this write method will write this pass string to the file. So, if I run this, you can see in the output we have got 9, that is actually number of characters that are to be written into the file. So, that is written here. Let me close this file now, fl5 dot close, and now if I want to read the lines that are part of this file, so I can use this bit block bit open temp.txt, where we have just now written appended as fl6, and I will record I am using another method read lines to read all the lines that are in that file, and I'm storing that in the lines variable here. So, if I run this, I will have lines, and again if I execute this, so you can see this list of strings, the last element is appended. So, you can see at the end of all the at the end of the file, this particular string has been written. If I try to open this file in another file mode, write w mode, then if I try this fl6 open temp.txt w, because so whatever content that is there, this file is already existing. So, whatever data that is there, that is going to be erased here. If I run this now, here if I try to just read this file, because this is open in the write only mode, so I won't be able to read here. So, you can see not readable, because I need to open the file in the read mode. So, first I will close this, and then I will open this file, open path, and then I will read this, and you can see we have got the empty bytes object, because we had used the write mode and for an existing file the same file name. So, therefore, all the data, all the content that was there in the file, that was erased. So, we would like to stop at this point, and we will continue our discussion on file management in the next lecture. Thank you.